In this video, you will see the affine transform or geometric transform in Python. We can use two different methods to use affine transform. First, here, the transformation matrix M can be given here by two rows and three columns here. And we use warp affine function to apply this transform to the image. Here, for resize the image, the first element in the first row and the second element in the second row can be changed. Here we use 0.8 to scale smaller, for example, and we can do the different types of transformation, as you know, rotation, horizontal and or vertical shear, and translation. Here, for example, to resize the image 0.8 degree, here when we use it, okay, this is the output. It's the rescaled in X and rescaled in Y coordinates. If you give more than one, here 1.2 for example, in Y coordinate, it's larger, it's getting larger. Okay, for rotation here, here we have cosine time the degree, the pi over 108, sine, minus sine, and cosine here. This is the rotation transformation matrix, and for example we choose 10 degree counterclockwise. Here when we apply this, it rotates 10 degree counterclockwise. And for example, for 20 degree, as you know, it rotates according to the origin, and the origin is here 0, 0 point. The other transformation matrix, affine transformation matrix, is shear. We can do a horizontal or vertical shear. For example, for horizontal shear, here, as you can see, the second term, we give a point here, we give a value here. Normally, it would be 0, but if we want to shear horizontally, we give a positive number here. We do the horizontal shear, as you can see. If we give a negative number here, it's shear other way. And we can do vertical shear using the second term, the second element of the second, the first element of the second row here, for example 0.2. This is the vertical shear. And the last transformation matrix is translation, which means moving the object on the image. This is 50 on X coordinate. This is 100 pixel on Y coordinate. On X, here we have 50 pixel, we move it to the right, and we move it to the bottom on the Y. This is the first method. Here we give a transformation matrix and apply it using warp affine. The second method is giving the 3 points here and to give another 3 points to transform the first points to the second points. For example, the first point 50 will go to 1000. The second point 150 will go to 250 of the same point. Okay, it keeps the same, but the third point 50 to 200 will go to 100, 250. For the same image here, we give first point set and the second point set. Then, by using get affine transform, we obtain the transformation matrix. It's very practical, and we use this matrix here for the transformation using warp affine. Okay, this is the output. You can change every point, but here we use only 3 points. Okay, this is used for two-dimensional images. And here in warp affine, this is the output image columns and rows of the dimension. You can change it by multiplying or giving any number.